So we have the total amount of emission, which is E, and we have a unit tax on the emissions, H. Then firms has to pay H times E. What is the problem of the firms? Is to choose the level of abatement. Why? Because if the firm abates, then the firm will pay less taxes. Okay? The lower E, what is abatement? Abatement is reducing E. It's fine? So, if I reduce E with abatement, I will pay less taxes. At the same time, I will have to suffer some costs in order to abate. So I have this trade-off. The more I abate, the less taxes I pay, but the higher the cost. That's fine? So I can pay less taxes, but I will have more abatement costs. So we can define the total abatement cost. We have some kind of functions, and the firms will minimize the sum of the total abatement cost, which is a function of the amount of the abatements, plus the taxes, H times E. Where E is the level of the final level of emissions. And of course, we need, so we can write the final level of emissions as the initial level of emission minus the abatement minus the reduction in emissions, which is E0 minus A, the initial emissions minus the abatement. So you can write minimizing total abatement cost, which is function of A, plus H times E0, the initial level, minus A, which is the abatement. We simply expressed the objective function of the firms in terms of abatement. You could have done also the opposite, to express everything in terms of emissions. Is it clear? You could define emissions and abatement. So what does it involve? The condition of the first order condition is, of course, you have to do the derivatives as with respect to A. And then you will get the marginal abatement cost, which is the derivatives. What is the derivatives with respect to A? Is minus H. Is that clear? Hence, we will get this condition, that is, the firm will choose an optimal abatement level, A star, such that the marginal abatement cost is equal to H. What is H? The tax. The tax level. Okay? Doing this, the firm will minimize the sum of the abatement cost and the tax. So we will get the target at the minimum cost. Let's try, so the higher H, the higher the abatement. Let's try to make, you will have this in Italian, which is exactly the repetition of what we say. So if you want, as a curiosity to see how is it in Italian, it is like it was written in this slide. So let's do an example. Suppose that the total cost of abatement is 3/4 times A squared. So what is the derivatives of that? What is the marginal cost of abatement? This is the total cost of abatement, and the marginal cost of abatement is 1.5 times A. Okay, can you do these derivatives? Is 6 quarters, that is 3 halves. 1.5, and this is a marginal abatement cost. And when H is 7.5, we need to equalize the marginal abatement cost and the tax level, and so we will get that the optimal abatement is 5. So please, we can move to the issue of cost effectiveness, which is the reason why economists like these taxes on emissions. Suppose that E max is the target of the government, the maximum level of emissions that the government desires. And suppose that in order to get this level of emissions, we have to have some abatement level. We have to ask to the firms to reduce their emission. And so we can write that we have a minimum level of abatement, of reduction of emissions. And suppose that we have only two firms. So we need that the total abatement of the two firms is A min, which is the target of abatement. We can have a target in terms of emission or a target in terms of abatement. We did our model in terms of abatement, but we can do in terms of emissions. It is the same. So the idea is that as a government, I want to minimize the cost of compliance, the cost of getting the target as a government. So as a government, I want to minimize the abatement cost. I forgot an A there. Total abatement cost, the total abatement cost of the first firm, and the total abatement cost of the second firm. I want to minimize that. At the same time, I want to satisfy the constraint, equation number 1. So I can combine 1 and 2 and express the objective functions only in terms of abatement of the first firm. I just did the substitution. Can you see here? Rather, instead of A2, I put the target in terms of abatement minus minus A1. Now we can do the derivative, and of course we get that the marginal abatement cost of the first firm must be the same as the marginal abatement cost of the second firm. This is the way to minimize the total costs of getting the target. Now, again, two firms. Now it's difficult and easy. What do I put on this picture? The same as before. Abatement for firm 1, and suppose that the target is this one, is A min. And suppose that the first firm alone is the only one that abates. Okay? So this is the maximum level of abatement which is asked to firm 1. In this case, firm 1, if the firm 1 abates at A mean, this means that the firm will alone abate for getting the target. Is it okay? So we can imagine this picture, this as a constraint. The first firm will not abate more than this A mean. And if this firm abate A mean, what is the abatement level of the other one? What is? Of course, is if one firm gets the target, what is the abatement of the other firm? Is 0. Is it okay? We have a target, which is A mean. We get the target by summing the abatement of the first firm and the second firm. If the first firm does all of the job, so get alone the target, the other firm doesn't need to abate. Is it clear? So in this point, the abatement of the firm 2 is 0. And what about O1? Suppose that firm 1 doesn't abate, and everything is abated and the target is reached by firm 2 alone. Okay? So we can think that this O1 is also A mean if firm 2 abate at this level. So we can kind of, we notice that. So now we can draw the line of the marginal abatement cost of the firm 1. But now we can rotate the axis. And we can put the arrow going the other way, so from right to left. If I add this arrow, it means exactly what we were talking about. That this is the origin of the second firm, and then this is the more we go to the left, the higher the abatement of the second firm. Was I clear? And so we can draw the marginal average cost of the second firm. It's only a graphical trick. We can draw the picture either in this direction or in this other direction. Okay? And we can combine the two. So by combining the two, we get the distribution of the abatement. That is, we can think that this is A1 is the level of abatement of the first firm. And if we read from O2 to A1, we have the amount which is abated by firm 2. And in this point, the marginal abatement cost of the two firms is the same. As you can see, this is different from the standard, because we don't know what is... so the different firms behave in a different way. And why? For the first firm, it is not very costly to abate. Okay? So the first firm preferred to abate a lot rather than paying the tax. The second firm. For the second firm, it is rather costly to abate. So the first firm prefers to have a lower amount of emissions, but paying more taxes. And if you think about the standard, no? And we go back to this picture, and what is this blue area? This blue area is the total cost of the policy, because you can do the integral and you can sum all the small bits and of the marginal cost. So this is, we will go very quickly because the lecture has ended and we need to go, but this blue area is the total cost of intervention. Suppose that you have a standard, and just make a standard, and because of the standard, firm 1 has to abate up to this level, and firm 2 has to abate again at this level A1S. Okay? What is the cost of the first firm? The cost of the first firm is lower, okay? Because it's only this area, this red area. But the cost of firm 2 is given by this triangle. Okay? So if we compare with the previous result, we can notice that we have this triangle which is orange, which is the loss, the deadweight loss, if you want, that we have if we put the standard. Okay? So only by chance, if by chance the standard is at this level, then the two tools are the same. But usually, normally, if we have some taxes on emissions, each firm can play in his best role, as in a volleyball match. And they are not obliged to do the same, to abate the same level, to have, okay? So this is the message of that. This is cost effectiveness. It's kind of efficiency. It is minimizing the total cost of the policy, of getting there.